Hello there, welcome back. Welcome to my YouTube channel. So today I'm going to show you how to calculate bridge score, because we are going to calculate this one today, and we're going to finish up our tutorial series on the calculation of bridge score that we are going to do today right now. So before going to calculate the bridge score today, I'm going to give you a little bit of recap of the previous tutorial that we have done on this series of tutorial to calculate the bridge score. What we have done in the first part of this video series, we imported the geometry from Excel file that we have, and we generated the geometry, right? And then in the second part of this tutorial or the video series, I have calculated and I have demonstrated basically how to calculate the 100-year return period of a flood level and a flow rate or discharge at the same time, right? So by this time you know how to do that. And in the third part of the tutorial series, I have demonstrated how to insert the bridge information and how to insert the piers of the bridge, right? We maintain a certain length of a span and vertical clearance. So we know how to do that, how to import geometry from survey data, and how to calculate 100-year or 50-year or 25 years of flood water level and flood flow rate at the same time. And you know how to insert the bridge. So now everything is ready. So today I'm going to show you how to calculate the score around our bridge piers, right? So what do we have to know for this one? We need to have our collected bed material, bank material, just at some locations. So I already have that one. Here is the file. I'm going to show you that you need the sieve analysis for that one. Once you have that, because see, I'm going to show you these figures. I have the data collected this data has been collected by the same survey company we assigned for collecting the cross sections. So they did it, right? They did it at the same time. So what I have done, when I have this bed material and they collected this material from the bank, left bank, right bank, and just close to bridges because we have other bridges as well on the same river. So we tried to even analyze what are the bed material, the distribution of the material as well. So here you can see the curve, right? The grain size distribution curve. Along the x-axis we have the sieve opening in millimeter, and along the y-axis we have the percent finer. For most of the calculation we need D10, D50 or D90, right? So we can even get the value. So I plotted this one, and I also have the distribution curve for the bed material. And here you can see on the right bank we have the gradation curve that is pretty normal, but for bed material you can see it is pretty fine. The material, the curve is a little bit different than what we have for the left bank, and for the right bank we have the same, right? The material is kind of finer. And we also have other locations as well, because they collected for some significant stations they thought. And here we can see the curve for this one as well. So this material was so fine. What we have done for this one, basically we conducted the hydrometer analysis for this one, because you know, if you have the bed material that is finer than 200 number sieve, then you have to use hydrometer test. So that is another kind of test. You can explore that test if you didn't. So once we have this information, bed material information, so we have to open our previous model. Let me just open that one pretty quickly. And here it is. I have to find that it should be in my D drive, and from that one, I think it's there inside here, and then HEC-RAS and bridge scour model, this one, okay? So I'm gonna open it. So here is the model I'm just developing for the last 3 part. But I also have other information, right? I already demonstrated how to run on a steady flow model, and I already demonstrated another different floodplain alternatives in separate videos. If you didn't watch that one, you can watch that. Okay, so here it is. I inserted these sections, cross sections. We have total number of cross sections, right, as 20, and then you can see we already run the model, and here we have the bridge, right? For the time being we fixed our span as 50 meter. Then we have 3 different piers, and we know the size, the dimension, everything, right? The vertical clearance, horizontal clearance, we know everything. So now what I have to do, I have to calculate the scores, right, around this bridge pier and at the same time these are the abutment we have. There will be some abutment scour, and since we are just constricting the river, the flow path, the conveyance area is reducing, so there will be another scour due to constriction. So there will be 3 different types of scours, and we'll calculate that one today. So how can you do that? I'm closing this one, and then if you want to really do that, you have to open again that bridge, or you have to go to this main window here, and then from run, because for calculating this one, the first criteria is to run the model. Once you are done with the hydraulics, right, you have the velocity, you have the water depth at every stations, right, at every station possible, and you have the bridge already inserted into your model, and then you can go to run and then hydraulic design functions, because these are nothing difficult. It's pretty simple. They're just calculating the scour using some empirical equations. See, if you click on that one, it's opening your bridge section. Right here you can see that. Once you are done with opening this bridge section, so you have to select, if you have multiple river and ridge and you have different plan, we have, right, 25 year, 50 year, because we calculated that one. That's why it's there. We have the option, even you can calculate. So I'm gonna select the 100 year, right, 100 year flood event. So that's what we need. And here we can select the bridge location, since we already have only one bridge in between section number 4 and 3. So the bridge section is 3.5, right? So here you can see construction, right? And then you have that pier, and you also have abutment. So what we have to do, we have to provide information for that one, okay? And then we can calculate. So these are the constriction or due to construction. So there will be some reduction of conveyance area, right? The flow area will be reduced. So then there will be some scour, because the velocity will be increased from the normal flow rate. So that's why we have to count that one as well. So here we need Y1, we need V1, we need Y0, we need Q2 and W2 and D50 here. So these are the information we need. So for channel, we already have that values because we calculated that one. We run the model, you can see, since we run the model, right, we already have that. And you can select different equations we have. You can select live bed, you can select anything. If you select live bed, it will be different, okay? So you can even play with that one, fixed default or that one. So if you put it as default, so that's that. Even you can manually import the data, even you can do it, and you can select here default, right, it will be default value. And then you have to fix there what is the approximate cross-section number. So the just upstream of the river, we have the bridge, right, in between section number 4 and section number 3. So for this one, what we have to select, we have to select, see, it's already there, 5. So it is not the just immediate section, because this bridge section, it is the section number 4, even though the number is 3.5, but the approach section means it is just upstream of the other section. It means if you put the bridge in between section number 4 and 3, so you have to select this section, the approach section, as section number 5. So that will be upstream of section number 4. So that's the condition you have to do, because the model or the equation, it will start calculating from that one. So it is a little bit away from the upstream section of the bridge. So that's why you have to provide that one, and by default it will be there. You don't have to do anything, just I'm explaining that one. And if you are not sure about what is Y1, what is V1, so see, since this is LOB, means left bank, and that is the right bank, so what you have to do, you have to even give this information, or you can put it as it is. If you want to even calculate, because this is construction score, so it will calculate only the score for the channel. And if you put these values here, it will calculate the score for bank as well, left and right bank. So how can you do that? You can even go to that section number 5, and you can calculate the velocity. So that is the depth of water on the left bank, and that is the depth of water on the right bank. That is the velocity. These are basically the mean velocity, and Y1, that is the mean depth. And usually what we use mean depth as the hydraulic depth. If you are familiar with hydraulic depth, it is basically the area of the cross section divided by the perimeter. It is called R, hydraulic radius. A divided by P. Okay, if I wanna draw this one, that is called R, we call hydraulic radius. It will be A divided by P. P is the perimeter, okay? Perimeter. If you have a section like this one, and if you have flow depth of water there, right, that is the water symbol. If you have Y, right, so that will be the length of P, right? P, that is the length of P. You need to know the slope of this side and this side. Usually these are same. And if you know the area, right, if you know the area of this cross section, and then if you divide this cross section by P, then you will get the R. So this has to be this Y1. And what will be the average velocity? So that is the depth average velocity V1. And you have to, you can use the same velocity, and you can use other velocity as well. So if I can calculate the velocity, and if I check it from our model simulation, because automatically this model and this value, you can see the blue color, this has been taken automatically from that simulation and the report we have. So even I can replace the values, or even you can modify these values as your requirement. You can do that as well. Or what you can do, you can even insert. So for this case, I'm gonna insert the values, and you can even try this way, 0.99, and I already have the values there. Now on the right side, the depth is not that high. I'm gonna insert this as 1.94, and velocity, it will be like 0.35, and on the right side you can put it same, or you can even use 0.26. I'm gonna use this one, and you can follow that. Okay, and for Y1 or Y0, this should be 0.98. I'm gonna give you the explanation right away, don't worry. So it is 0.85, and then we have Q2, right? That is the flow rate. And see in the channel, we already imported this one, 6300 from our 100 year of flood level. We calculated that one, and this model is taking that values from that. Okay, since it is a steady flow calculation, so it is taking the boundary condition, right? So here we can even import 2.29, and here we can even import 0.10. On the right side, we don't have that value, and W2 is the width of the river, so that is the top width of the section. Okay, here, so you have to select that values. It is not that big, 5.71 meter, and we have that. And on the right side is pretty simple, 0.72. And then the D50 from that CV analysis we have here, right? For the bridge section, from the bridge section you can select. So we have that upstream of bridge section number 5. That is the approach section. That's why we have the value there, and we also have the distribution for bridge, right? So that is the bridge section BR. And if you want to calculate, right, the D50, how to read that graph, just follow D50, right? And here, and it will be like there. So this is 0.1, 0.2, so that will be 0.15, okay? 0.15, so put it there. Once you have the value as 0.15, you can use for the left bank, or for the left bank, you have to even use different value for the channel. So let me check. We have, right bank, this is for right bank, and you can, for left bank, it would be different. See, it is not even covering, so you can even use value 0.008. okay, it is not covering. Even you can use the minimum value 0.008, or you can use 0.10. And for left bank, right bank, and for Tolweg, that is the channel, you can even use that one. Okay, so what will be the value for 50% or D50? It will be 0.12. okay, so we got it, right? We got the value, and we can insert it there right away. So left side, it will be 0.10, and there it will be 0.15, and here it is gonna be 0.12 as well. I'm gonna use these values, okay? And here we can even use the live bed specific data if you want to calculate, because there will be some scouring and sedimentation, deposition, everything. So we are using live bed. So that will be 2.76 for this case, and that will be 0.46. Okay, and then we have the width 8.07, and we already have that values from the simulation that we already have done here. And then for the calculation of K, you can even click there and you can calculate it because it is already there. Okay, and if you click OK, then it will just fill out these values for you. So we are done with that one, right? We are done with only construction. So if you are not familiar with what we have done here, so what you have to do, you have to click help, right? You have to click on help and it will automatically open this window and you can see which parameter is which. So you can see the exact same value or same figure we can see, and it is a little bit different, right? So you can even identify the description from here and how to enter these values, right? And they're gonna give you the explanation. Here you can see Y1, the average depth, basically the hydraulic depth in the left bank, main channel, and the right bank. Okay, so at the approach cross section, so this should be the cross section number for 5, right? So this should be for cross section number 5. So that is the Y1, and V1 for the same one, the velocity, right, in the left over bank, main channel, and the right. And Y0, what is that? The average depth of water. It is the depth of water, right? And you know Q2, that is the flow in the left over bank, main channel, and the right. So you know that. And what is W2? It is the top width, right? I already demonstrated that one of the active flow area. And what is D50? It is the bed material particle size distribution, of which 50% are smaller for the left overbank, main channel, and the right overbank at the same time. So this particle size must be entered in millimeter, right? So we already entered by ourselves, that is by the user. And you can select any equation you have. There are different options. We're gonna select the default one, right? And we know what is Q1, the flow in the left overbank, main channel, and the right overbank, right? At that first cross section. This is for same cross section, section number 5. And W1 is the top width, and K1 we already calculated that one. Okay, so these are the options. See, if you want to calculate K, so you can even click that one. We did it, and we have the values there, and we're done with that one. And you can even enter the pier Scour data. We're done with construction. Then we can click on pier. See, and it is also populating everything because that is the pier size. We know that, right? The diameter, and we already entered the D50, so it is there. And Y1, it is already there. And Froude number, since the flow is supercritical, it is less than 1, it is already there. And here we can even select different equation, right? We have that CSU equation, Colorado State University. That equation is called CSU equation. And we have another equation that is another equation. What is the name of this equation? Froelich, okay, Froelich equation. So we are not going to use that Froelich equation. We are going to use another CSU equation. That is the most popular one. People are going to use that one, and you can read the manual. You can see they're even going to mention that one. See, the Colorado State University CSU equation and the Froelich equation. So basically, they're going to use that CSU equation here as well. Okay, so we're done with that one. But here we have to enter the angle. See, the angle, because we are going to use, what are we going to use? We're going to use a diameter, right? That's why it's round. So there is no angle. So what will be the angle for this case? That's why it will be 0 for round. And here the length is not 5. The length is 1.5 meter. So we have to be able to check everything. Okay, and what is K1? We are done with that one, right? K1, we know that by default it is there. And what will be the value of D95? So we have to select those values from that graph we have. D95, it has to be from Tolweg because we have the piers. And if you have the data, separate data for separate piers, that is more useful, but sometimes it is pretty difficult. If your river width is so big or so long, you can do that. Otherwise, for this river, it is not that wide river, so we are going to use this one. So it will be 95. So this one, okay, we can go to there, and it is 1, so that will be what, 90, okay? D95 is 90, this one, 90, 0, 9. So the value will be 0, 9. So we can put it there, 0.90, and we don't need anything, okay? If you use the other equation, then you need these values. So for this one, we don't need that. And if you want to even calculate, we're done with pier, apartment. So these are the apartment, right? Apartment. When water will flow through this side and this side, definitely there will be some collision and there will be some scours, right? So here and here. So that's why we have to calculate the scour around the bridge pier and here as well, around the apartment and due to construction as well. If you construct the bridge, there will be some scour, right? Because the bed material, that will be like loose material. So that's why you have to calculate all of them all together and you have to sum them up to get the total scour for your bridge. So here it is, apartment scour. If you click there, it will activate that one as well. And then you can see all values are already there. Our width of this apartment is 4 meter. That's why we have this, right? 4 meter, 4 meter, 4 meter, everything is there. On the right side, we have the coordinate, everything is ready. We don't need to do anything literally. So what we can do right now, if you just click compute, so you are done with that one. And if you are not sure what to do, so go to this manual, right? That's the simplistic way to get the information. If you are confused with any parameter and if you don't know what to do, go there and check it and you'll find the value. And if you want to even select other values from your default one, you are welcome to change that. You don't need to even maintain the same thing. Even you can even check, right? If you want to change it to 4, right? Change it to 3 meter or 5 meter from whatever you have, you can test different scenarios. So then you can manually change it and you can calculate, right? So for this case, I'm selecting only one profile, which is 100 here, and I'm keeping as it is. I'm just showing how to calculate bridge scour, that's it. But for reality, I tested multiple combinations and scenarios. Then we selected which one is giving us the worst result. And based on the scenario, we are suggesting that, okay, we have to calculate our total scour based on this apartment scour, maximum value of apartment scour, pier scour, and construction. Then we can use piling or whatever necessary treatment we need. And based on this information, even we can suggest some bank protection work, right, on both sides, the upstream and downstream of the bridge. So here's the manual. You can even follow that one as well, and you already have the description, right, one by one, pier number, D50, this thing, what is that? So if you are not familiar with this one, read it. You have to read it. It is not even convenient only to watch these videos and do whatever I'm doing here. It is not convenient. You have to learn. You can learn it from there, and it is not possible to explain everything here because I already went through all of this thing and I know what it is meaning. So that's why it's pretty easy to import or input any value, right? But if you want to know what is these values and actually what it is meaning in real world cases, so you can check. You can go to see any bridge physically, then you can check what are the components, right? I had the same problem understanding what is the apartment, which one is the apartment. I didn't even understand that one. So then I try to visit a bridge and then I check it, because from this sketch or figure you can't even see which one is which, right? So that's why as an engineer we can, or a student, okay, who is learning engineering, who may not have that knowledge on that one, and you can go to visit a bridge and you can inspect that one, and then you can see which one is which, and then you can get an idea about that one as well. So once you are done with everything you inserted, then what we have to do, we have to click compute, right? If you click on compute, then definitely it will compute the values that you are gonna calculate. Okay, see, we're done. Just hit the button and it's gonna show you the scour. This is dotted line, you can check, right, which one is which. That farm line, this one, that is because of that See, if I click there, that is the apartment toe. That is the apartment, and this is the toe of the apartment right here along this bottom of the cross section. And then total scour, can you see that? That is what we need, total scour. So this apartment on the left side, we have less, like what is the value? It is close to, we don't know the exact value, we'll see that from the report. It is even like 6, 7, 8, and there on the right side, see, you have like minus 20. Can you imagine? So you have to treat that. If you didn't know this information, then what would happen? So this will be, right, this amount of soil will be washed out if you construct this breeze. And if you have a flood that is 100 here, and if you have that flow rate 6300 cms, and then what will happen if you didn't expect that one, and if you didn't construct the breeze after considering all these values, then definitely the breeze will be washed out. So we have to consider that one. And now you know the information, right? And if you know the scour will be minus 20 or whatever the total number, and this is even not correct. If you consider only minus 20 because you are getting it from the model, that is not right. You have to even apply factor of safety like 1.5, then it will be minus 30. Then you can make sure that, okay, minus 30 is enough because we got the value from the model as minus 20 and we are applying the factor of safety as 1.5. So that is the thing we usually do, right? So when you are done with that one and you are not sure about the exact value, so go to report here, and if you want to see the report, go to report, and it's going to give you the entire report, right? So we have the input data here. You can see what data we have provided the model, and then you can see the scour depth YS, that is the value. On the left side you have 0.09, and the channel you have 2.47, and on the right side you don't have that one. So that is basically the construction scour. So construction scour is not that big, it is pretty normal, and we have the critical velocity and the equation we used here for live bed. Okay, and for pier, and you have this input data and the result you can see. For piers we have the YS 4.24. For construction we have, for the channel, consider for the channel 2.47, and here we have 4.24, and Froude number is that, and we use the equation CSU. And what about the apartment scour? You can see the information we have, and we can see the results. For apartment you can see 8.47 on the left side, and for apartment we don't have the value for the channel because we have only two apartments, one on the left side and another on the right side, right? And see, on the right side we have 16.18 meter. Can you imagine the big hole there? And then we use this equation, right? VE, the velocity, we have this velocity. The velocity is also pretty big on the right side. That's why we are getting that huge scour there. And then we have the Froude number as this one because the flow is still subcritical. And equation we use for apartment, right? Freilich equation, that's that. And when you are combining everything, see, can you see that? The model is automatically calculating the value. So what they're summing here, pier scour plus construction scour. For channel we are getting 6.71. So for construction scour we have 2.47, and for pier 4.24. If you sum them off, you will get 6.71. So that is for channel, right? So you don't need to even treat your breeze for apartment, right, while you are treating your piers, because piers are usually located on the channel, right, on the main channel, and the apartment, these are on the other side. So when we have very high flow, then you will have overbank flow, and that will be even affecting, right, that left bank, right bank, and also the apartment as well. That's why you have to calculate this scour separately. So for main channel you have to sum that construction scour plus that pier scour, then you will have 6.71. and if you multiply this one by 1.5, right, and you can take it as 11 or 10 right? That's that. And for left abutment, see, abutment is Scour plus construction is Scour. So on the left side you have 11.2 and you can multiply it by 1.5, it will be more than 15. And here on the right side you have that right abutment is Scour plus that construction Scour. So what do we have? Right, that is the contraction Scour basically, because of this constriction. I mentioned that one. When you will have the breeze, that's why I sometimes call it construction. Means when you construct the breeze, the flow will be constricted. That's why I mentioned previously it is constriction Scour as well. So because of the contraction of the flow, you will have a contraction coefficient, right? There will be a contraction coefficient, means the velocity that will be increased when you construct something, right? So this is sometimes called constriction Scour. So what we have, it is 18.65 on the right side. So we have 11.2 on the left side and we have 18.65. And if you just multiply by 1.5, then definitely you will get the value, right? And if you are sure about everything, then you can go with that one. Otherwise, what do you have to do? You have to even use the same equation, and you can even write this function in either in MATLAB, in Python, or you can use an Excel sheet to calculate the same values. So you have to check, you have to make sure by hand calculation, and you have to use this model, because see, we are clicking only once and we are getting the value. So this may not be right? You may even, because most of the time we are using this equation, that equation, and in the model we don't have many options. But in reality, or if you use hand calculations, because there are a lot of equation, right, for calculating Scour, so we can even use those, and then you'll get the minimum value from either hand calculation or from model. So you have to use the maximum value, because these are the rule, right? You have to select the worst situation where we have the highest Scour and we have highest velocity, flow rate, everything. Then if you construct the breeze based on this worst condition or situation that may occur in future, then your breeze may survive for 100-year flood, right? Otherwise it will be washed out. So if you have any design fault, and if you're not experienced on that one, if you didn't face that problem previously, so that's why you need experience on that. You need to study, you need to even check, double check, and after checking all these things, everything is okay, then at the very last moment you have to apply the factor of safety, either as 2, either as 1.5. so it depends on the necessity or urgency or the importance of the structure that you are gonna design, right? If it is very important structure, right, then you have to apply more factor of safety, and then your construction cost will be increased. So this is how we have to manage, and we have to optimize your cost and your services or the material, everything, right? So that's that. Once you're done with that one, even you can save the report, you can even check, right? You can even check everything, and then you can save this as, go to file, copy to your clipboard, and if you want, you can paste it there. You can paste it there, here, right? And you have this report as text file as well. See, it's pretty simple, and you can write your report and you can put it there. So that's that. So that is the end of the tutorial series for the calculation of breeze Scour. And if you want to play with that one, you can do. Even you can, right, use uniform flow. For this one we are using this one. You can even use other parameter as well. You can even calculate sediment transport capacity, double channel design. If you want to design a channel, you can do that here. So everything is possible. If I get time in future tutorial, I'll show that one, because see, in the manual we have, after that computation, right, scouring, they have the option channel design or modification. If you want to modify your channel, the cross section you already have, and if you want to even modify this cross section, and if you want to see what is going to be the effect of modifying the cross section of the channel, then you can do that. Okay, let me just want to have a sip of water. Okay, So in future video, maybe I'll demonstrate how to perform channel design and modification, and you can do that using your empirical equation or the hydraulics we know, right? From Manning's equation or from Chassis equation or from any other uniform flow equation we know, you can use that. Even we can use non-uniform flow. So for the same thing here, instead of using uniform flow, you can even use a non-uniform flow, right? I already demonstrated how to generate a model for non-uniform flow. It is because of the boundary condition. If you import a time series of flow rate that changes with respect to time, right, then it is going to be on a steady flow, because time is the main criteria for determining whether a flow is steady or unsteady. If the flow rate means the discharge and the velocity, the depth of water, these are all constant, right, with respect to time, then we call it steady flow. Otherwise, if this parameter or hydraulic parameter changes with respect to time, then we call it unsteady flow. So if you import a boundary condition where you have a flow for 6 months or 1 month or 1 year, whatever the time is, if you have the daily flow rate, and if you insert this as your upstream boundary condition, then if you run the model, then if you have a breeze like this one, and if you want to calculate the Scour that we already have done here, then definitely it will run the model, it will calculate, and it will be dynamic, right? So that is another one. So here, what instead of doing that, what we have done here, we selected the maximum, right, highest high water level at the very downstream of the breeze, and then we already calculated the 100-year of return period of the flow rate. Then we use only one value. We're giving only one value. Okay, if I have this one value, then what will be the Scour? So that is another approach. So for simple breeze, simple model, we can use that one. And if you want to even use that unsteady flow condition, you can do that. So that is the task I'm giving you. You can try that one by yourself, because I already demonstrated how to run unsteady flow model. It's there. It's nothing not difficult, right? If you are already done with my previous tutorial, you can do that. So that is the a little explanation, or that is the pretty good idea that I have already gave you, right? Already given in this tutorial series. So I'm not gonna make it longer. So that's that. I'm gonna finish up here, and if you have any query or question, you can post it there in the comment box. And the data, you can even follow this one. I'm not gonna give you any data anymore because you don't need that, right? You already have the data. I already provided that cross-sectional data in my first part of this video, right? And then I just followed, and I already demonstrated, maybe I already provided the link for that, for the calculation of 100-year flood level. You already have that data, and for this one you don't need that. You can use the same value because most of the data will be imported from the simulation run that you already have. So you can calculate that one, and for your purpose, for your real world scenario, because the model I already demonstrated here, this data is basically for a real world engineering case. So this is basically a practical example, and the data all are from a real world engineering case. So you can rely on this one, and basically these are the design, and this is how engineers design any bridge, and they suggest that bridge, and then other people, the people responsible for constructing the bridge, they follow this thing. They will follow whatever you suggest, right? The vertical and horizontal clearance. See, you will have the water level, 100-year water level there, right? That is the 100-year water level, you can see. And then you'll have this part of the bridge will be covered by water, and then you'll have only this gap. And if you want to even pass any ship, big ship, so you'll have only this room, right? And you have to pass the ship within this limit. Then if your ship is higher than this empty space or blank space, then definitely there will be some disaster. That's why you have to consider all of these scenarios, so that in future there won't be any collision with the bridge, either with the high chord, low chord, or on the abutment, or even there won't be any collision with the Scour as well. So these are the things you have to keep in mind while designing any bridge and if your design is accurate, and if you suggest to construct that as per the rules and regulation, then definitely the bridge will survive for the design period as well. So that's that. Thank you very much for watching this video, and if you have any query or comment, either it is good or bad, and if you have any suggestion at the same time, and if you want to criticize my videos, you can do that, so that in future videos, if it is possible and if it is within the limit of my capability, I'll try to improve my the thing that you will suggest. Okay, so that's that. I like to improve myself, so I'll really appreciate if you have any suggestion how to improve this tutorial as well, and you can be benefited from this one. So thank you very much once again, and stay safe, and bye.